Okay, in this video we're going to have a look at putting a quadratic expression in the form x plus a all squared plus b. This is also known as completing the square. Now in this video we're going to look at the most basic examples that we can, where the coefficient of x squared is going to be equal to 1. So for example, x squared plus 4x plus 7. Okay, so we want to put it in the form x plus a constant all squared plus another constant, and the way that we do this is to find the number that goes in the bracket, we halve the coefficient of x. So the coefficient of x here is plus 4, so when we halve it we get plus 2 all squared. Then we're going to subtract the square of this constant, which is 4, so we're going to take away 4, and then we're going to add 7, which is the original constant. And then we're going to simplify this down to give us x plus 2 all squared minus 4 plus 7 is positive 3. Now obviously I haven't explained why this works. This is just how to answer the question and put it into the correct format. If I try another one, x squared minus 6x plus 3. So I'm going to start, I have my x squared, my coefficient of x is minus 6, so I halve that to go in here, to give me minus 3. Then I'm going to subtract the square of this value. Well, minus 3 all squared is 9, so I subtract 9, and then I'm going to add on the constant that I want, which is plus 3. So this then gives me x minus 3 all squared minus 6. Okay, we can actually tell something about the quadratic curves from these two forms that we're in now. So I could sketch the graph of both of these. So I'll look at the second one. Using your f of x notation, we've got a basic x squared graph, which is a U-shaped graph that goes to the origin 0, 0. When we apply this completing the square form, it sends a transformation to it where it translates the x squared curve, so that inside the bracket it shifts it left or right, and it does the opposite of what you're told. So instead of shifting it or taking 3 off all the x values, you're actually going to add 3, so it's going to move the graph 3 to the right. So if I sketch this, okay, so it's going to go 3 to the right, and outside of the bracket it affects the y-axis and does exactly what you're told. So this is going to send the graph 6 down, so down to minus 6. So your x squared graph is going to look like this, and it's going to come down, and it will have a minimum point by here. So depending on what you're asked in an exam, you could be asked for the minimum point. So the minimum point is 3 across, so 3 on the x-axis and minus 6. Or you could be asked for the minimum value. So the minimum value is, so if you follow this curve down, it's in an infinite height over here on the left. It comes down, 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 lower and lower and lower and lower and lower. It gets to this point here, which is called the stationary point, and it then starts increasing in value again. So at your stationary point you have your minimum value. So your minimum value is here at minus 6. And that happens when x equals 3. So that means if I put 3 into here, so 3 squared minus 6 lots of 3 plus 3, then I would get minus 6 coming out, and there isn't any other value that could be lower than minus 6 coming out. Okay, if I try another one, slightly more complicated this one, x squared minus 3x plus 1. So we start with my x and squared. Now my number inside the bracket comes from halving the coefficient of x. So if I halve minus 3, now I could write this as minus 1.5, but it's better to write minus 3 over 2. And the reason being is when I need to subtract the square of this, it's a lot easier to square 3 over 2 to get 9 over 4 than it is to square 1.5. Then I'm going to put the constant on that I want, which is plus 4. Sorry, plus 1. So what I'm now going to do, because I'm dealing with fractions, and my fractions are quarters, I'm going to write this whole number in terms of quarters. So every whole number has 4 quarters, so this 1 is an extra 4 quarters, and then that leaves me with x minus 3 over 2 all squared. So minus 9 quarters plus 4 quarters is minus 5 quarters. And then if I sketch the curve, the minus 3 over 2 sends me 3 over 2 to the left, oh sorry, I should say 3 over 2 to the right. So it sends me to 3 over 2 there. My minus 5 over 4 sends me minus 5 over 4. So my minimum value is here. So it comes down, comes back up. So again, the coordinates of my minimum point are, in this case it's 3 over 2 minus 5 over 4. Or, you know that the minimum value is, so it comes down, 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 down until it gets to its lowest point here. So the minimum point is minus 5 over 4, and that happens when x is 3 over 2. Okay, I've just got one more quick example, just because I know students could get confused with this. X squared plus x minus 2. So we start with x, and the squared, the number that goes in is half the coefficient of x. Well, the coefficient of x here, even though it's not written, is 1. So that's plus a half, all squared. We're going to take away the square of this, which is a quarter, and then I'm going to take off the 2. So this then leaves me with x plus a half, all squared, minus a quarter. Again, I'm dealing with fractions here, so I'm going to write 2 in terms of quarters. So if every one whole is 4 quarters, then 2 wholes are 8 quarters. And when I tidy this up, I get x plus a half, all squared, minus 1, take away another 8, is minus 9 quarters. So if I sketch my curve, this now goes a half to the left. So that's at minus a half, and 9 over 4 down, so minus 9 over 4 down. So my minimum point is by there. So if I sketch my curve in, I can then say that my minimum point is minus a half, minus 9 over 4. Or I can say that my minimum value is, so it comes down, 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 down until it gets to here at minus 9 over 4. And that happens when x equals minus a half. Okay, that's the basics of completing the square done.